minimum spanning tree. Spanning tree is a tree that connects all vertices of a graph, so all the corners. And one more thing, a few things to remember when making spanning tree. A tree cannot have a loop. It cannot have cycles. So something similar to this. So a tree cannot have a cycle and a loop. And also, if a tree has n number of vertices, it will have n minus 1 edges. So the number of vertices minus 1 will give you the number of edges in a tree. So let's have a look at this example and see how to form one. And also another thing to remember is a tree, every vertex choose the smallest weight, in other words, the smallest attachment. So this vertex here, vertex A, has got 3 attachment, and that's the smallest. 2 is the smallest. It has 2, 5, and 6. And vertex C has 3 attachment again, so that's the smallest. And vertex E has 3 attachment again, so that is the smallest. We choose the smallest, we pick the smallest. And also one more thing to remember, all vertices need to be connected. So if you look at this graph here, it's like it's 2 sections, there's no connection. So we need to make sure we connect also that. So to do so, we pick the smallest way to connect. So we have 3 ways of connecting this section of the graph. So 5, 6, 7, and 6 again. So we use the 5 because that's the smallest weight. And again here, we have to also connect this vertex is like standing by itself. This edge is standing by itself. So we need to connect those. So we pick 5 because 5 is the smallest. And here we go. That's the tree. Again, we don't have a cycle. And it also fulfills this requirement. So we have how many numbers? That's 3, 4, and 6. So 6 minus 1 is 5. So we have 5 edges. 1, 2, 3, 4, 5. 5 edges. There we go. It fulfills all the requirement. Doesn't have a loop. Doesn't have a cycle. And also n minus 1 is the number of edges. Okay. Now let's have a look at another example. And on this stuff, minimum tree. So again, we pick the smallest weight every vertex. So this one, this vertex A has, it doesn't matter which vertex you start from, but it's always easier to use the outside ones rather than the inside. So, and that's the smallest weight. Again, this one here, that is the smallest weight again. And E, that is the smallest weight. It has 4 attachments, 3 attachments, I should say, 5, 6, and 2. And also, and we need to, these 2 are attached, so even F, that's the smallest weight. So we need to make sure that we connect the whole graph. To do so, we have to connect CE, because CE is the smallest weight. Okay, so now again, if you look at the graph and put a line in the middle, you sort of find that this section of the graph, that will be isolated vertices, and this will be a connected vertex. So we don't want to have that scenario. So we want to make sure the whole vertices are connected. Again, so we're just going to pick 5 is the smallest weight. So that gives me a total of what? If I do the total, so that's going to be 2 plus 5 plus 3 plus another 5 plus 2. It's going to be 10, 15, 17. So that's 17. It takes 17. So 17 is the smallest. All right, let's have a look at another example. So this is a VCA exam question, and which is a minimum tree. So this is question 5, 2019 exam 1. So we're going to do a minimum span on this one here. This one has more vertices than the ones we have seen before. All right, let's do it. Again, the concept doesn't change. So the main server, that's where we started from. So we pick the smallest weight. So that's the one with the smallest weight. All right, and we're going to do the same with, and so this one here will be that's going to be the smallest weight. It has got 3 attachments, 28, 35, and 30. 28 the smallest. And again, so we need to also look at these other ones. So this one here, G and C and G. So that's going to be the smallest weight. Connect those. So F, so 32 the smallest weight. So we do that. So again, we have got G has got 2 connections, 30 and 40. We pick the 30. So we have also, and B has 3 connections, 28, 40, and 38. So we pick the 28. That's the smallest one. And again, so we have A for 2 connections. It has 36 and 35. So we pick the 35 because that's the smallest one. And again, it doesn't actually form a cycle. We don't have a cycle. We don't have a loop. And also it fulfills n-1, which is the number of edges. All right. Now, so let us add all the numbers and find out what is the minimum length that's required for this networking. So by the way, that's where we use a network, connecting computers. Minimum spanning. 15, 28, 35, 28 again, 30, 32, 35. If you add all this, it gives us 203. That's the minimum number, the minimum length of cables required for this. And that is the third example. I hope that's clear for minimum spanning tree.